Welcome to Chatter. I'm David Priess. This week, Dr. Mariel Borowitz on space diplomacy and satellite data.
So I teach a course on space policy, and it used to be that if I forgot to update the slides one year, that was fine. It was basically the same as last year, but the last 3 to 5 years, that's not true at all. The rate at which we've started putting satellites up, it's probably doubled. You develop these satellites, they're clearly very useful for weather, but for all sorts of other applications. And then some, particularly those looking at the budget and how expensive these satellites are saying, hey, can you sell that data? And so then you have to stop and ask the question, not just what can they do, but what should they do, right? What are the functions or the capabilities that we really want government control over as opposed to commercial?
Mariel, thank you for joining me on Chatter.
Yes, thank you for having me.
I am jealous because I have looked at your CV or resume, if you will, and you are who I want to be. You have been a systems engineer and a research analyst at the Space Foundation. You've worked at NASA's Science Mission Directorate. You've got degrees in everything from aeronautics and astronautics to public policy and international science and tech policy. And you teach space, but you teach with the International Affairs School, the Sam Nunn School down at Georgia Tech. Wow. How did you get so lucky to be at the intersection of all of these cool things when most people don't carve out a space that way?
Yeah, I appreciate that. It's definitely at the intersection of things that I love as well. So I always loved space since I was, 8 years old, something like that, and was just one of those kids that stuck with it. And so I originally studied aerospace engineering, which I loved and loved math and science, loved doing, learning how to build rockets and that kind of thing. But I also, from pretty early on, was fascinated by just learning about the world and other cultures and other people and how, how we coordinate things around the world. And so, when I started looking at going to graduate school, I came across this program in space policy that's run out of the George Washington University. And it just sounded, perfect to me because it was a mix of those two things that I loved. So that was kind of my first introduction to really putting the two things together and understanding how we do international cooperation for space projects and how we deal with the international and global dimension of space. And I really have just stuck with that ever since then.
There are about 8 billion professors of international relations of one stripe or another. How many people are there who actually specialize, as you do, in what we would call space diplomacy?
Oh, gosh. I would say probably only a handful, in the tens at the most. And I probably know most of them.
Yeah.
It's a relatively small community, that works at this intersection.
And how do you define that space? Because that intersection could be really broad or really not. It could be as broad as, let's send some diplomats into space, which at times I've felt, or it could be definition of anything having to do with the commons that could touch on space. So how do you put some limits on what someone who studies space diplomacy is actually focused on?
Yeah, that's a good question. I actually do interpret it pretty broadly. So I'm interested in when we have issues related to the space environment and they require international cooperation or international coordination. And this happens almost always with space, because as you mentioned, it's an area that no one owns. All countries are meant to be able to have access to it, to use it. So whether we're talking about, Earth observation satellites and data we gather about the Earth, maybe we're talking about the space environment in itself and trying to keep that sustainable, avoid debris or collisions. All of those are areas where we need to have that international dimension and that international coordination. So those are all, I would really include all of those different areas.
All right. I'm going to hit you with a few then to see whether you feel like these are areas that are squarely within that area, or whether they're on the boundaries, or whether you just roll your eyes because people will always ask me this stuff, even though it's not really my area. So first of all, we're recording this right after some significant solar activity that led to some remarkable aurora in some pretty relatively southerly latitudes for the aurora. At the same time, you're talking to me via an internet connection of Starlink.
Hmm.
Um, any sign that the activity that we had last night that caused those beautiful sights that we're seeing all the images of this morning, any sign that that is causing any interruptions to Starlink or other significant satellite activity?
So typically, you wouldn't expect to see any long-lasting effect. So the space weather events like that that'll cause the aurora and make that really beautiful scene might have an immediate effect as they're coming through. So they'll kind of change the shape of the ionosphere, for example. That can affect communications a little bit. Um, but for them, and they can also, because they're bringing in these highly charged particles, they can sometimes affect satellites and cause different kind of electronics issues. But you're going to know that basically right away. So as that aurora is happening, as those particles are coming in, you would find out. So I haven't heard of any major problems with the constellation or with other spacecraft. So probably nothing major.
And I'm going to put a sticker on Starlink to come back to later in a different context.
Mhm.
Okay, we have the Artemis missions, and they're, I don't want to say full steam ahead. That just doesn't sound right in several ways. But Artemis missions are being planned, and not too long ago it was announced that there is an international crew. It is a NASA and CSA joint crew, Canadian Space Agency as well. Um, what do you make of that? Does that fit into space diplomacy to look at things like the makeup of the crew, or is that too tactical?
No, I think that's definitely part of it. And, this is one of the interesting things about working on, international relations in space is there are issues at every level, right? So I think human space flight, certainly, you look historically in the space race and its role, in global relations between the United States and Soviet Union, right, is this huge geopolitical undertaking, right? And we have that dimension of Artemis as well, right? The US developing this big moon program, China and Russia have a moon program. So you have the international dimensions on that level, but then in the planning of the program itself and the way you carry that out down to, as you mentioned, the specific crew that will be on each of the missions, and how do you build in that international component from the beginning? How does that change the way the mission is perceived? How does it change the way the mission is maybe funded or planned? Right, all these different dimensions fit together.
And then at the other end of that is the recent creation of the Space Force and the
Hmm.
Guardians who will be in space. So it's not the joint cooperation and exploration of space, but it's actual militarization, too strong a term, but the military's focus on space changing somewhat. How does that enter into the study of space diplomacy?
Yeah, so I think in a couple ways. So one, with the Space Force, a lot of what they're doing are things that the US military has been doing for a very long time, right? It was embedded within the Air Force and Air Force Space Command. So operating GPS, thinking about monitoring space debris, letting people know if there might be a collision, all of those things were being done previously, but I think the Space Force is a recognition of the importance of these missions and the amount of focus we need to have. And I think that goes along with this broader awareness that space is a congested and contested domain, right? There's a lot of stuff up there that we need to uh, be paying attention to and watching, even if we think everyone's being a good actor, that kind of space safety side of things. And then, space security, that there is potentially some bad actors in space, right? Or a potential for conflict to extend to space. So I think Space Force recognizes that competitive element of space. But then there also is coordination on the military side. So Space Force works with other allied militaries to carry out some of these missions. So with monitoring space debris, for example, there are international military individuals who sit in some of um, the spaces in the United States where this work is being done. So we have people from the United Kingdom or elsewhere in Europe, from Australia, that are there coordinating on the ground. So there's that type of cooperation and diplomacy as well.
I feel like we are fairly well prepared for these nuances of joint missions and Space Force, which is both competitive and cooperative,
Mhm.
because of some of the movies we grew up on. I mean, 2001, and then, the sequels, especially 2010, it did have some international angle to it, right? It was
Mhm.
Russia, the United States, the rise of China. That was predicted in there. That was there. You've got a lot of the other movies that have to do with space exploration end up having some, usually not a major part of the plot, but something about the international situation going on at home and how that's complicating things in space, right?
Yeah, absolutely. I would add, The Martian, which is a great book and then a
Yeah.
great movie, and The Expanse, right? That really bring in that political and international dimension to what's happening in space.
I'm thinking about The Martian, and if I have it right, Arrival as well.
Mhm.
Uh, there's really interesting exploration of the Chinese angle and the fact that kind of on some things we have to cooperate, whether by some choice of our own in The Martian or by a choice pushed upon us by others in Arrival. And yet it's always portrayed in a way that's very simple, that there's just one person who has to make a decision and then it's clear cut action. But as we'll talk about in depth, there's a whole lot of actors that come to play in these
Yeah.
decisions. And those movies may be very fun in their own ways, but I'm not sure they get the space diplomacy right.
Yes, it's definitely a lot more, complicated and a lot slower than would probably work well for a movie.
Hmm. Hmm. Another thing I wanted to ask you about is your work at NASA. I know you've given
Mhm.
some presentations to people who have not, about what it's like to actually work at NASA headquarters. Can you talk about that a little bit? Because I think NASA is one of those government institutions that, unlike so many others, still has this, if not magic or mystique about it. It still has a lot of kind of cultural resonance with the American people. And having worked at NASA, you probably get questions like, "Ooh, what's that like?" more than most people who work, at the Treasury Department or the Department of Agriculture do. So, what are your highlights when you're trying to talk, especially to young women who might be going into something having to do with aeronautics, astronautics, other areas? What is it you tell them about what NASA is actually like to work at?
Yeah, that's an interesting question. Working at NASA headquarters was a lot of fun. It was a great experience, and it's a funny place in some ways because NASA headquarters, it's based in Washington D.C., and it's not the place where they're building hardware. So out at
Right.
Kennedy Space Center, out at Johnson Space Center, Goddard, right? That's where they're kind of building satellites, building spacecraft. Headquarters is mostly cubicles and offices, right? So I think on the tour you don't get to see that sort of hardware, but when you go every day, just the culture of working in that building and in that community, you definitely feel that you're working at NASA. And the amount of excitement that people bring to their job day to day just really makes it a great environment to be on. People are excited to be there. People care about what they're working on. They're really passionate, and just being surrounded by that all the time is great. And then, and I think I have the same feeling. So I was there, I'm maybe working in a cubicle or an office, but
Mhm.
the stuff I'm working on is, what are the Earth observation systems that we have operating right now? What are the future missions that have been proposed by scientists working on the decadal survey? How do all those things fit together? How do we coordinate that with our international partners? How do we help get that message to Congress of what the vision is going forward? So thinking about all those types of issues and sharing that message, to me is something I care about a lot and feel passionate about. And so yeah, it was a great experience to work at NASA headquarters.
I got a small window into that several years ago when I went up to give a talk at the Applied Physics Laboratory in Maryland.
Hmm.
And if memory serves, it was the New Horizons mission that was being, I don't know what the word is, managed, operated
Hmm.
from APL. And obviously, it was not a highly active mission. It wasn't like an Artemis launch was going on. It's a
Hmm.
mission that's more than a few miles away, and there
Yeah.
wasn't anything going on right at that time, like an intersection of Pluto or something like that. but yet the
Mhm.
people that were around, there still was that buzz. There still was that excitement of this is just freaking cool. This is awesome. This is the mission that Brian May, the guitarist from Queen, actually worked on as an astrophysicist. That's
Yeah.
just amazing to me. And that's just a small slice compared to NASA. I'm guessing that the people who work on some of these projects for decades, and that's one of the cool things about NASA and its related agencies and entities, is you do have some people who stick with the lifetime of a program.
Mhm.
I would think some of that magic gets lost on their own program because they're doing the day-to-day bureaucracy and program management. But I get the sense that they still have that childlike glee about the projects going on around them.
Yeah, I honestly I think it's both. I think being surrounded by it and you're gonna bump into somebody in the hallway and they're gonna be working on something amazing, right? Or getting ready for a launch or, there's always something cool happening in the building. But people, you know, even decades into working on the same program are excited about that program. I mean, I really did encounter that, time and again. There's the bureaucracy, there's the day to day that everybody has, even if you're at NASA. But yeah, you get people started talking about the missions that they've worked on. Whether it's something about to launch, something that's on its way to the mission, or even things that are have been like Hubble that's been operating for a very long time.
Yeah.
People are very passionate about it.
Yeah. The James Webb Space Telescope obviously has gotten a lot of attention recently, and in some ways it's like the gateway drug that Hubble was decades ago for getting people interested in deep space again. But perhaps through the lenses of deep space, getting more interested in our own neighborhood and exploration issues too. What have you found, especially with students, in terms of what JWST is doing for interest in your field?
Yeah, that's an interesting question. I It is such an amazing mission. I mean, think just from a engineering perspective, how they built this, it's I think about the size of a tennis court, but it's basically folded up like origami. It was folded up to get it launched into space, and then it has to unfold on this, thousands of miles journey to get to where it's going to be stationed. So it's amazing from the engineering perspective. The science that it's starting to collect is also pretty incredible. Uh, when you're looking at things as distant as Webb can look, you're essentially looking back in time,
Mhm.
right? So you're starting to learn about the history of the universe from very early times, which I think for whether you're in astrophysics or not is pretty mind blowing. Um, so yeah, I mean, I definitely think it is something that piques everyone's attention, everyone's interest, including the students, and just the idea of having brand new information, brand new imagery that no one has ever seen before, of
Mhm.
a clarity and capability that just was never possible is, yeah, it's pretty incredible.
What has caught your attention the most in the things you've seen or the data you've seen coming in?
Oh gosh, from Webb in particular,
Sure.
I, for me, I think it's just been seeing individual images and just
Mhm.
I think the thing that gets me is just the scale
Yeah.
of the stuff it can see, right? That
Mhm.
looking at tiny areas of, when you look up at the sky, it would take up a tiny area of space, but there are all these stars and galaxies and just so much out there. So much more than you even realize just looking at the expanse of the sky. So I think that to me is still mind boggling. I'm also excited to see some of the exoplanet stuff that's going to come back.
Right.
So getting to really get better data and understanding of these planets around other suns, other stars. I mean, that's also incredible.
That's a good point because, I mean, you have not been in this work area that long, but back when you were just starting to get into the field, I mean, we knew about exoplanets, but it wasn't a thing yet. It wasn't where we are now with, I don't even know how many thousands or tens of thousands of defined, confirmed exoplanets. Uh, it's remarkable. And especially what we're learning about the ones that are cosmically really close.
Right.
And the
Yeah.
great diversity that we've found already is just fascinating.
Yes, exoplanets in general, as a study, I think is extremely interesting because, as you said, it's gone in just a few decades from being essentially a theory,
Hmm.
maybe planets exist around these other stars, to yes, they exist, and we can get information about them and understand what elements they might have on them, and whether they have water, and whether they're of a size and a distance from that star that they could potentially have life. I mean, it's yeah, I think it's come so far so quickly, and it's amazing to think what with these new tools like Webb, how much more we can learn in the near future.
Of course, Webb is just one of literally thousands, probably tens of thousands now, of satellites orbiting. And that's another change in recent times is we used to be able to count them relatively easily. But now with these constellations of, I don't know what the term of art is, microsatellites, but the idea of shooting up dozens or hundreds of smaller satellites that work
Mhm.
together rather than just shooting up one big bus-sized platform, it's gotten a little bit harder to say exactly how many satellites are in orbit right now.
Yeah, absolutely. It changes quickly. So I teach a course on space policy that
Uh-huh.
I typically teach at least once a year. And so I always, at the beginning of the class, I talk about, how many satellites are up there, what's the breakdown by country or by type. And it used to be that if I forgot to update the slides one year, that was fine. It was, basically the same as last year.
Hmm.
But the last 3 to 5 years, that's not true at all.
No.
If you don't update, you're off by, it's probably doubled in that time, right? The rate at which we've started putting satellites up, particularly with Starlink, is really kind of the
Mhm.
standout. But other sort of very large constellations, yeah, it's just you can see that turn in the curve where it started to really ramp up the number of things we're putting up there.
Talk a little bit more about Starlink in particular, because it is different in a couple of ways than the way we traditionally think of satellites, both in terms of provenance and in terms of operation. So, describe Starlink to us so we all have the same understanding there.
Sure. So Starlink is a constellation of small satellites that are used for communications, for providing internet. Um, and prior to this, we've had communication satellites, commercial communication satellites for decades, but typically they were at a higher altitude. So they're farther away from the Earth, which means any individual satellite can see a really large area of the Earth and they can serve a lot of customers from that one location. So you can think, for example, of the direct to home TV. If you have one of those satellites that just points, or one of the satellite dishes just points at the satellite. And you really only need a few of those satellites to cover the Earth. But one problem with those is the amount of time it takes your signal to go all the way out to those very high altitudes and back is enough latency that you can't, have a normal conversation or play video games, right? It's just a little bit too slow for those kinds of uses. So what Starlink did instead is say, okay, we're going to come close to the Earth, a very lower altitude, but then you need a lot more satellites to get that same coverage. If you want to be able to always be able to communicate with at least one of those satellites anywhere on the Earth, you need a lot more of those. And so they are planning to have many thousands, tens of thousands of satellites in low Earth orbit eventually. Right now, I think they have a few thousand that are already up there and already providing some service. But it's a huge change. Some of the largest constellations we had prior to that were, maybe Iridium. I think had 66 satellites, right? But
Mm-hmm.
that's a lot of satellites, but it's not thousands of satellites. So it's a
Right.
real change in how we do things.
And with, I mean, when we're talking about space, even low Earth orbit, even I can't comprehend how large this space is we're talking about. When you start moving three-dimensional outward, it gets really big really fast.
Hmm.
Uh, but there's a difference from 66 satellites, if that's what Iridium was, to thousands or tens of thousands or hundreds of thousands as others get into the game. What's the deconfliction like for these relatively low orbits when you do suddenly have tens of thousands of smaller vehicles up there operating?
So this is actually an issue that I think about a lot and work on a lot, which we talk about. Space situational awareness is the first step, which is just knowing what's up there, tracking those different objects, both the operational satellites and spacecraft, but then also all the debris that ends up, all the kind of junk, satellites that died or things that fell off. So tracking all those things and trying to predict when might there be a collision. So that's just kind of the information side of it. And that what we're trying to work towards is space traffic management or space traffic coordination, which would mean actually doing something about that. And just the way with air traffic, we have a process for making sure that things are not going to collide and deciding who has to move if there's an issue. We're working towards that as an international community, but it's challenging because there is no national space like there's national airspace, right? So you can't be in
Right,
control of a
right.
particular area. You really have to all work together in the entire volume. So yeah, I think we're doing a decent job right now of tracking things and making those predictions about when there might be collisions. And I would say the United States has the most advanced system for doing that by far, and it's the U.S. military that actually does that job and
Mhm.
provides warnings to anyone in the world, no matter who you are, Russia, China, commercial, and everybody can get these warnings. But at that stage, the way we operate right now is it's up to you as an operator if you want to do anything and what you want to do.
Mhm.
So you might get that collision warning, but then you can say, we're
Yeah.
feeling we're feeling all right. We'll wait and see what happens, right?
Yeah. Well, there are some parallels here that help somewhat, but probably only go so far. I mean, we've had areas of the commons before where countries have learned to get together and come up with compacts, whether it's Antarctica or the oceans or just international air travel. We found ways that countries have gotten together and found something that works as a coordinating mechanism. But as you mentioned, space is different. It's not like there is airspace over a defined geographical area when you're talking about, you know, some orbits. It doesn't quite work the same way. So in terms of this kind of intersection of international relations and space, what do you find are the benefits, if you will, of borrowing on those previous examples? And what are the real drawbacks of using those as analogies for how we're going to cooperate on these issues?
Yeah. So I think it is important to look to these other documents and these other places where we have found ways to cooperate or ways to coordinate to try and build on those. But as you mentioned, space is a pretty unique environment. And so the speed at which things are operating, the freedom they have in terms of the different orbits that they might be in, right? All different nations are sharing all the same space. Uh, and the amount of time you need to kind of plan these maneuvers and make changes, it just creates kind of unique challenges, right? So if you imagine there's some work that has compared it to air traffic control or ICAO is the organization internationally that coordinates air travel. Similarly to some of the rules at sea and kind of rules of right of way for ships, for example, that we have some international agreement on. And there definitely are some things that are applicable, and I think largely conceptually, the idea that you're going to have some sort of right of way rules or you're going to have some coordination on uh, which areas to use in which ways, right? I think those concepts can port over to space. But the specifics are tough because you're, like with the example at sea, um, you don't necessarily have the ability to see the other objects around you in the way that you do when you're in the ocean, right? So you're getting that information from someone else. There's multiple different providers. They're not going to give you exactly the same information. So and there's a lot more uncertainty, right? You're not just looking and seeing it with your eyes. It's there are algorithms involved in kind of predicting where these things are going to be. So definitely some additional complications that get added there that make it hard to do an exact connection.
We spoke earlier on the podcast with Aaron Bateman, specifically
Mhm.
about the issue of space debris and Hollywood's representation of space debris issues. Most notably, I think gravity is what most people think of when it's an issue of cascading effects of
Sure.
space debris, and of course, an international dimension there, which is yes, you can have some significant issues with orbital debris from a missile test in space or a
Hmm.
designed collision to test out a certain kinetic kill vehicle in space. How much do you study those issues in particular, the what we would call the militarization of space and how it could affect other satellites?
Yes, this is definitely an area I've looked at, partly because all of these different issues are so closely tied together, right? So if you are worried about this issue of accidental collisions and how to coordinate on that issue, you also need to be concerned about the creation of more debris or maneuvers that are maybe being carried out for other reasons, right? How that's going to affect your ability to do this safety mission. So, you know, I think there are, near term things that people have tried to do. So the United States, for example, this past year made a unilateral statement that we would not do any more testing of direct ascent satellite weapons that create debris. And the U.S. has really encouraged other countries to follow suit and make similar statements, similar unilateral statements, and a number have done so. And there's also some work happening right now within the United Nations to come up with norms of behavior for responsible actors in space. And I think this is an interesting one because it's happening within the United Nations system. So it has, the United States and Europe and others participating, but also Russia and China being a part of this conversation. So you really have that full um, global conversation going on, and just trying to at least get some basic agreement on uh, the US, Russia, and China, for example, all have the capability to maneuver objects in space. And they'll sometimes maneuver their spacecraft and put them close to, for example, someone else's spacecraft. Um, we know those capabilities are out there and they've been tested, but can we all agree, for example, how close is too close? And now you're really creating a potential safety hazard by maneuvering yourself too close to someone else's satellite. Can we come up with some agreement on things like that? So there's a process happening right now to see if we can make space a little bit safer, even on that sort of security military side.
And there's a real bifurcation here that on the military security side, and honestly, that's my limited familiarity with this comes from that having worked in the intel community. It was
Mhm.
just the kid coming in and seeing what we were able to do with satellites and having my mind blown away. And that was a long time ago now, so I can't even imagine the advances in technology now. But that was information that was not even widely shared within the top secret community, much
Mhm.
less shared internationally in the information being passed around. You've extensively studied the other side of it, which is the global effort for open access to satellite data, particularly meteorological, environmental, and related issues. In your academic articles, some of your more public facing articles, even your book Open Space, you've examined these issues of why nations make data from some space missions available, why some of them make it freely available, why
Mhm.
some of them don't, and then why those decisions change over time. And I'd like to talk about some of that because it's a whole area that most people take for granted that of course we know there are weather satellites, and most of us if we think about it know that there are other climate related collection platforms in space, but we don't think about the fact that that data needs to get to scientists and how that actually happens around the world. So walk us through the evolution of this in particular, starting, with the U.S., but then with other countries and consortiums in Europe and elsewhere from the 1960s through the 70s and 80s. How did information sharing and data sharing from these satellite platforms evolve, and what did you notice as the patterns when it came to actually sharing the data with the scientists who needed it?
Yeah, absolutely. So it's a really fascinating story. So what originally brought me to this issue is, we have all these Earth observation satellites, these satellites that are looking down at the Earth, collecting environmental information. And just because of the nature of the way satellites work, they're going around the globe collecting information about not just one country or one region, right? But global environmental information. And what I found when I started looking at it is about half of the satellites that had been launched up till about 2016 when I wrote put together the data and started writing the book, about half of the data, half of the satellites, the data was shared completely freely. Anyone could use it for any purpose. So that means if you want to do environmental science, if you want to develop a new application, new company, you can get that data and you can use it. But the other half of the satellites, their data was restricted in some way. So either you had to pay for the data, you had to go through some application process to request it. It can be lengthy, and it can be difficult. And so I wanted to understand why was there that difference. And I also found that among the data that was openly available, a lot of the policies that had been put in place to have open data happened before the national movement to open data. So even before you had, if you remember, to the Obama administration, for example, this open data.gov kind of websites and things.
Yeah.
When those were set up, NASA and NOAA and these other the space agencies, their data was already open. So they actually were, very quickly able to put a little check mark next to their name and say, oh, we're complying with this new policy, because they had already had it in place. What I found when I tried to understand why this is that a lot of it can be explained through how the agencies see their mission and kind of the best way to achieve their mission, and also questions about the economics of satellite data. So this was really, I'll talk if we have time after this a little bit about the military and military data, how that's treated a little bit different.
Mm-hmm.
For the book, I was really focused on civil data. So this is your, non-military, NASA, the weather data. What I found with the weather satellites, which the US has, Europe, Russia, China, South Korea, when satellites were originally developed in the late 1950s, the weather community was already very aware that these were going to be useful for monitoring the weather. They had been, ever since the invention of the telegraph, they'd been sharing information globally freely about the weather
That's
around the
interesting.
world.
So it wasn't as much about modern government and the national security state, but the framework for meteorological data, even from satellites, was in the context of that 1870s forward evolution of this epistemic community.
Exactly. Yeah. These early, meteorologists, professional meteorologists realized, if I want to know what the weather is going to be, in Germany one day, I want to know what it was in France yesterday. Right. And so they're very early set up these systems for sharing data internationally. And so when satellites come on the scene, that community said, okay, these are definitely useful for us. They worked within the UN system actually to encourage the United Nations to call out weather satellites in particular as a place for peaceful international cooperation in space. There were letters written back between Kennedy and Khrushchev about cooperating specifically on sharing weather data and agreeing that would be beneficial for the two countries and for the world. And so weather satellite data has really been freely shared pretty much since those were developed. Just kind of following the kind of norms of that community. And then with the scientific satellites like NASA, you had a somewhat similar story. So they, wanted to make the data available to the scientists, of course. They're a science agency. They want that science to be done. And they got a little pushback at various stages in NASA's development because there was interesting commercial activity as well. So the question was, you develop these satellites. They're clearly very useful for weather, but for all sorts of other applications. And then some, particularly those looking at the budget and how expensive these satellites are saying, hey, can you sell that data? Is there a way to, take all that value and get some economic benefit from that? And so there are a number of agencies that experimented with kind of commercializing that data. In the US, our LANDSAT system, which was originally developed as a government system, was fully privatized. So it went from being free data available to scientists and to others to being, there was a kind of a process where the government started selling it about $400 per image, to kind of knowing that they were going to go commercial. And then when it went fully privatized, it was about $4,000 for a single image from the Landsat satellite. And they made some revenue when they were doing that, but not enough to really cover the whole operation of the satellite, and certainly not enough to build the follow-ons and things like that. So,
Remind me, Mariel, about
mhm.
Landsat. What did Landsat do that other systems weren't doing?
Yeah, so the Landsat system was the first civil land remote sensing satellite. So
Mhm.
if you think of, the weather satellites we had for a long time, they're taking pictures from above, but they're seeing a lot of clouds, right?
Mhm.
A
Mhm.
lot of stuff in very little precision, right? So you can't tell exactly what's happening on the ground, and that's fine for weather. Um, Spy satellites from the very beginning had been taking imagery that was much more precise. You could see a lot more stuff on the ground. They're looking at areas. They're interested in the non-cloud covered images, right?
Right.
But that had been only on the security side, on the
Mhm.
military side, until Landsat came along. So Landsat was sort of the first civil satellite that was going to look at ground cover.
Mhm.
Um, and so it was of interest to scientists, but also kind of a big change in the international community.
And if I
Um,
understand your point right, the one of the differences is the meteorological satellites. Of course, weather scientists are interested in clouds, and there are some commercial issues related to that, but they're all downstream of weather forecasting and precipitation and issues of like that. Whereas for Landsat, there are some very specific commercial uses for that don't require the mediation of the scientists, right?
Right. So you can use Landsat imagery for agricultural purposes,
Hmm.
for forestry, for fishing to some extent. So a lot of different. I think the mining industry was interested in that kind of imagery. So lots of different potential applications. And now the commercial satellites we have are much more precise even than Landsat, and can do
Yeah.
even more stuff. But yeah, so there was a much broader pool of interest for the Landsat imagery.
Hmm.
And so that was the idea with kind of privatizing and saying, okay, can we sell that?
Right.
Um, and like I said, it made some revenue, but it didn't make a significant amount of revenue. And so it was basically either the whole program was going to fail and be over, or go back to government control. And they realized that while they couldn't make a lot of money selling Landsat data, um, that data was extremely beneficial for science, and particularly for climate change, because already, you know, this whole privatization and move back was happening 20 years or so into the program. And that means we had 20 years of history of
Hmm.
monitoring the Earth with this same type of instrument.
Yeah.
And that's just, there is no other source of data like that. It just doesn't exist. And so they kept it as a government system, and they made the data free again, particularly when the internet came around, and they could just put it online for free, and the distribution of the Landsat data skyrocketed. So it went from like the highest distribution when it was, you know, hundreds or thousands of dollars a scene, was about 25,000 scenes in a year.
Hmm.
Um, a couple of years after they made it freely available, they were sending out 25,000 images a month. So it
Wow.
was, and very quickly going to millions a year, and
Hmm.
yeah, huge distribution now. So that movement to an open policy really made a big difference.
I'll show my ignorance probably here, but my recollection is that when it came to a lot of weather satellites, that there was the institution called NOAA that
Hmm.
administers a lot of that, and that's kind of been the home for a whole lot of, at least in the U.S., meteorological study for a long time. But Landsat never had a stable home. It was kind of passed around between agencies, departments, entities, and that probably led to some differences in terms of how it was seen as a money-making venture or not.
Yeah, so I think, when you think about these two issues, are what is the mission of the agency, where that's running the program, and then the economic issues. Because, as you said, Landsat didn't really have a clear owner agency. It kind of got moved around over its lifetime. Um, there wasn't that clear, this is a science agency. We need to make it available freely, because of science, or we're a weather agency, and we need to make it available for that reason. So it was the U.S. Geological Survey was very active in Landsat early on, because they're an agency that uses that type of data, right? They make maps, they do all sorts of things like that. Um, So they were interested in it, and they actually are the ones who run it now. But it's their only satellite program. They're not like NASA or
Hmm.
NOAA where they have a whole bunch of different satellites.
Hmm.
And yeah, Landsat was at NASA for a period of time, but it wasn't really a science satellite in the sense that it's collecting medium resolution data, and the plan is to do that essentially forever, for a very long time period. It's useful for science, but normally the scientists want to, keep developing new types of missions to answer new types of questions. That's typically what you see NASA doing. NOAA, which does the weather satellites, they do have that long-term operational sort of approach, where they want to keep collecting the same types of measurements basically indefinitely, right? Keep monitoring the weather. But they do atmosphere, right? They do weather. They weren't that interested in monitoring the ground, so it wasn't a perfect fit there. So yeah, that's why it's sort of hopped around a little bit, but now is managed by U.S. Geological Survey.
So, how would you characterize in the US, and we'll turn to other countries next, but how would you
Mhm.
characterize in the US overall the status of availability of this kind of satellite data? Compare it to 10 years ago, 20 years ago, 50 years ago.
Yeah, so the U.S. is a leader in open provision of satellite data,
Mhm.
and has been actually for quite a few years. So NASA, from very early on, started making its data openly available. NOAA, with the weather data, has been openly available for many decades. Landsat, went through that process of privatization, but since about 2008, that's been a big leader in open data. Um, and I think one of the things that was realized in the United States, there was this tension with the economics, right? And what can you sell? And what they really found is that with this weather data and scientific data, um, that should really be government collects it, provides it to everybody. We use it for science, we
Mhm.
use it for weather monitoring. It's the high resolution imagery where you can really see very precise stuff on the ground,
Mhm.
or the very rapid revisit imagery, right? Where you
Right.
can look at things every
Yeah.
single day.
Yeah.
That's the stuff that has a lot more commercial potential. And
Mhm.
so while the United States is a leader in open data from the government, it's also a leader in commercial data. So it took some time. It wasn't Landsat, that ended up being the place to do this. It was these other commercial systems that the US did eventually really encourage and get off the ground to have this commercial remote sensing sector or commercial Earth observation. So it really has both.
It's interesting to hear you characterize it that way. The United States, the culture from early on was very much open, share data where possible on these issues. Because I seem to have this recollection of a few years ago in the National Defense Authorization Act that the U.S. Congress explicitly um, outlawed the United States military from using data from Chinese meteorological satellites. So on the one hand, the satellite culture, if you will, of these unclassified missions in the U.S. is to share the data. But when there is similar data out there that could complement our own meteorological understanding, something funny happened. And I don't know if it's the politics, the international relations, or if it's a different angle of the culture. But the idea was we have unclassified data from Chinese meteorological satellites, but we will not allow the US military to use it. Am I remembering that right?
You are, yeah. And so this actually a really interesting story. And I think the short answer is it probably comes down to the geopolitics, right?
Mhm.
And just the um, general discomfort that Congress in particular has in using data from China. But yeah, as we mentioned, the global weather monitoring system, the World Meteorological Organization, they coordinate all the global monitoring. There's open data sharing across the world. And the US uses data from lots of other countries and other sources. So we provide our data openly, we use other people's data. Um, the US has typically been a leader in the provision of weather data, and particularly from weather satellites. But the US went through this period in kind of the 2000s, 2010s, where we were going to combine our civil and military satellite programs into one joint program called NPOS. And there were just a whole book could be written just about that. There were a lot of problems with that program. And eventually, after about a decade, it got canceled without ever launching an operational satellite. So they launched one research satellite under that program, but that was it. And so that experience put the U.S. schedule for weather satellites way behind. And so there was a lot of concern for a number of years that there was going to be a gap in coverage from the United States. And since, that's an issue, of course, for the United States, we're not going to have our own satellites collecting the data we use, but it was also a problem for the world, right? Because we have this integrated system, others needed that data as well. And so on the UN side, the World Meteorological Organization, they actually went to China, which had also been during that period really advancing its weather monitoring capabilities. And they asked China if they could fill in that potential gap, right? And really take on more of the responsibility for global monitoring. And within the US, as we're trying to also figure out how to fill this gap, there was a report put out at one point that said, we should also use that Chinese data. That's, very high quality data. Their weather satellites at the time were similar to the US.
Mm-hmm.
And it could be, they even called it kind of the silver bullet solution. And that's when Congress responded that absolutely that was not going to be the solution for the United States, and made that very clear.
But that does seem odd because you already pointed out that in the early 1960s, presumably 62-ish, Kennedy and Khrushchev were exchanging letters about space cooperation, and there was some open data sharing, and that's near the height of the Cold War.
Mm-hmm.
But then suddenly with China in recent times, we're not willing to share safe weather information with a peer competitor.
Yeah, and I think two big things changed over that time period. So one is the technology and the way that it's integrated into our society. So back during the Cold War and the early years of weather satellites, I mean, they were useful from the beginning. The very first weather satellite, we could see a hurricane forming off the coast of Australia, and they'd send a telegram to Australia and warn them, right? It was useful, but it's not integrated into our daily lives, right? It's not integrated into the economy like it is today. So I think early on, it was useful technology, but it was really on the periphery, just getting started. Whereas today, accurate weather data and accurate weather forecasts are important for us day to day, but they're important to so many parts of the economy, whether it's air travel, recreation, all these places that need that. So I think the importance to our economy and to our security of that technology, and then also the way that we engage, the way that we engage with the Soviet Union, even though it was the Cold War, we had this this pattern of working with them in certain ways that just doesn't exist with China right now. And I think their, space is one tool in the kind of overall geopolitical tool belt. It's one way that you can engage with a potential adversary. But if, as a nation, we're not interested in that engagement, then, it's, even if you could have some practical benefit, it may not happen.
It's led to this interesting situation where it seems like the logic is we do not want to be dependent on a strategic competitor, so we can't do this. We can't have data that we're reliant on China for to fill out our meteorological picture. And yet the same logic of being dependent on a strategic competitor for more than 10 years, the United States has been completely reliant on the Russians to get US astronauts to and from the International Space Station. So you'd think that there'd be a little bit more examination of that, if not contradiction, that interesting comparison.
Yeah, absolutely. I mean, I think the national security ties and the ties to the economy are a big part of it, and are a little bit different in those two realms. But yeah, absolutely. And what outside options do you have is the other question.
Right. Well, we've talked a lot about U.S. systems. Describe the similarities and differences to the evolution of the European, initially individual countries, but eventually consortiums in Europe, as well as the Japanese, Russian, China's experience when it comes to the sharing of open data. What are the main similarities and differences with how you've described the U.S.?
Yeah, absolutely. So Europe, I think, has some similarities to the United States in the way they deal with their data, but maybe did it a little bit later. So their weather data, they have also generally been very open. Um, they went through a period in the 1980s where they were more aggressive about trying to commercialize some of the weather data. Um, and they kind of had the same experience that the United States had with Landsat, where they tried it. It didn't make a lot of revenue, and they also found that by kind of restricting access in order to sell that data, they really decrease the size of the value added sector, right? So all these companies that take the free data and make all these other applications and companies and other kind of parts of the economy, they weren't getting that, and so they transitioned then to a much more open policy for weather. And similar for their scientific data, they also made more of an effort for a longer period of time to sell that data. And they had something called a tiered policy. So if you were a scientist, you could get it for free, but you had to go through a whole application process, and you had to make sure it was only going to be used for science. But if you wanted to use it for commercial applications, you were going to have to pay. And again, didn't make a whole lot of revenue. And it's relatively recent in the around that 2016 time that they did put in a policy that said their Earth observation data, particularly the Copernicus system, is going to be fully free and open as well. So now that is their policy. So I think Europe ended up that same place just a little bit later. With others, like Russia, for example, um, a lot of their data is not openly available, but they were interesting because it's not so much that they're trying to sell that data, it's that a lot of their older Earth observation data, for example, is relatively low quality. There's some issues with it. So I actually had an opportunity. You can tell it's quite a while ago when I was writing this book, and I could have these conversations. But to do an interview with someone working at one of the Russian space agencies, and I was saying, what's the process to get this data? He's like, oh, you want the data? Oh, I mean, yeah, we could probably get you the data. So it wasn't so much that
Wow.
they had these barriers or were trying to restrict access necessarily. They just hadn't invested in any kind of systems to make the data openly
Mhm.
available. Um, so maybe the situation would be a little bit different now,
Yeah,
but
I would suspect so. I mean, what are you hearing from colleagues about even just that discussion about trying to access data? Are even those conversations closed down and there's literally no opportunity for some open access to some of this data unless it was already in the works?
yeah, that's a good question. I don't know what the status is of accessing Russian Earth observation data. Russia's space applications programs in general, and just their space program in general, has had a lot of difficulty with budget and has been somewhat constrained. So yeah, my sense is they're not putting a lot of investment right now in getting that data out to a broader audience, or even collecting a whole lot of Earth observation data on the civil side, at least to start with. So uh, yeah, I don't know the exact answer to that, but I haven't seen a lot of effort happening there.
I recall hearing or reading somewhere, maybe in your work, that Japan actually had developed some very sophisticated weather satellites, a little late to the game, but with US help, became quite a player in that area. Is that right? And whether correct or not, where do the Japanese agencies or departments that are involved here, where do they stand on some of this sharing questions that we're talking about?
Yeah, absolutely. So Japan does have really quite an advanced both weather monitoring capability with their satellites and also the kind of scientific Earth observation satellites. They have really a very large program there and very advanced. Uh, and they, with their weather satellites, they share again through this, World Meteorological Organization. So they participate in all of the kind of expected open data sharing within that community. Uh, and much of the data from their scientific satellites is also openly available. They have a few things where they have high resolution imagery that's collected by the government, and that they still have some restrictions on, or some efforts to sell that data. But all of the kind of scientific data and lower resolution data, that they've moved to an open data model.
Now, You mentioned that it's been a while since your book was published, and I think
Mhm.
all authors feel that way all too quickly as new developments come in. But it's only been about 5 years. And yet, even as someone who just has a tangential interest in this has noticed, and that would be me, one of the biggest developments, I think, at least again, from my point of view, is the growth of India's space ambitions.
Mm.
And I'm wondering how you see that evolving. I mean, China was already on the track that it's on now. That was evident in many ways 10 plus years ago. India seems to have made a strategic decision that it wants to play more in the space area. Do I have that generally right? And what does that mean for the issue of data accessibility in general?
Yeah, absolutely. So India has been a fairly large player in the space community for a while now, and it absolutely is growing. Uh, Earlier on, India tended to focus very strongly on space applications. How can we use space technology to help life on Earth? And so they actually had environmental satellites really quite early, and some pretty capable ones. They um, they also had, like Europe, a tiered policy. So they would give some data away for free to scientists, and they would sell some data.
Okay.
There was actually an interesting period when Landsat was privatized, that the Department of Agriculture in the United States decided that Landsat data was too expensive. So the US basically couldn't afford to buy the data from itself, and instead bought ResourceSat data from India. So they bought India's Earth observation satellite data.
That's brilliant.
So yeah, so there's all sorts of interesting things that happen happen during that period. So yeah, so India has had that data, high quality data. The U.S. was one of the purchasers of it, um, and they still have a somewhat mixed approach. They do have some data that is openly available, but there is a kind of commercial arm of their space agency that also looks at ways to commercialize this technology or some of the data and do some data sales. And they're growing. Their Earth observation program is growing, but across all different areas. They're looking at human space capabilities. They're looking at some of the space surveillance or space situational awareness capability that I mentioned. So all these things are areas of growth for India.
We touched briefly on the Russian invasion of Ukraine and its effect on the Russian sharing, but what are the other kind of big wild cards that could get in the way of some of this systematic sharing or prevent new potential providers of data that would change their fundamental view about how to share some of this open data?
Yeah, that's a good question. On the civil Earth observation side, that's kind of scientific data, environmental
Sure.
data, I haven't seen a big impact there. And I think one of the reasons is that to a large extent, that data is not seen as sensitive for national security. And so that type of sharing and that engagement has really continued to go forward. Where you have seen an impact with Earth observation satellites is on the commercial side. And this, I think, to some extent, has made it into the news. You maybe saw as the invasion was happening, these satellite images providing
Oh, yeah.
information to the public and
Mhm.
then also to Ukraine. So while Russia has a very advanced surveillance satellite capability, they have lots of reconnaissance satellites that their military can use. Ukraine had essentially none. They had one civil satellite, Earth observation satellite, but very early, they made a request to commercial remote sensing companies, commercial Earth observation companies, to provide data, to sell them data, so that they would also have this capability to see what was happening over the whole expanse of their country, over the whole conflict zone. And so the US in particular was very responsive to that. We have a quite a large commercial remote sensing sector. The US government really encouraged those companies to uh, make that data available to the public to some extent, right? That's those images you're seeing in the news, but also to Ukraine, and they help facilitate that. So I think that's where satellite imagery has really played a big part in the Russia-Ukraine engagement.
Some of the dystopian narratives about space, some, not always, but often have the the corporation that has monopolized some kind of technology or transportation or resource involving space. And of course, that leads to problems. And some people started to speculate with something like Starlink, which has obvious benefits in many ways, that if that trend continues, if many aspects of space satellites become more viable for a commercial firm than for countries with limited budgets that are being pulled in many directions, that you could have things like access to reliable weather data be, in a sense, held hostage by the evil corporation that runs that satellite network. Do you see that it's a possibility that we could be running into some of those narratives in the near future, and instead of it being science fiction, that it's reality, that the commercialization of space has some suboptimal outcomes for a lot of people?
Yeah, I think this is an important question to be thinking about. And I think this is a place where the government has an important role in thinking about what is the proper role of government. So, for example, going back to the weather example, um, there was a policy in place at one time that basically said, anything that the commercial sector is capable of doing, we'll have the commercial sector do that, and the government just does, whatever's left. There's these big expensive satellite programs, for example, only a government could do those, and so we have that. Well, it turned out, the commercial sector has gotten more and more capable to the point where the commercial sector can do almost everything that the government was doing. And so then you have to stop and ask the question, not just what can they do, but what should they do, right? What are the functions or the capabilities that we really want government control over, as opposed to commercial? And so, for example, uh, in the weather sector, you can imagine you could fully commercialize tornado warnings or hurricane warnings and sell those, right? And people would probably buy a hurricane warning or a tornado warning, right? But as a country, we don't believe that that is an ethical choice, right? We think you should know whether a hurricane is coming or whether a tornado is coming, whether you can pay for that or not, right? That's something saves lives, saves property. We believe everyone should have. And so that's a proper function of government to provide that, to collect that information and provide that warning. And so I think we have the same sort of questions happening now, not just in weather, but some of the worrying about the space environment, for example. There's similar questions going
Right,
on there.
right.
Who provides warnings about these collisions? Who decides what to do? And then, like you're saying, with some of the national security functions. So for Starlink and communications, right, that's a lot of power
Mhm.
in for one individual to be able to decide, where do I turn this on, where do I turn this off, what uses am I going to permit, and is that something that we want to be in privately held hands, as opposed to a decision that the government is able to make. So I
Mhm.
think there is growing awareness that this is an issue, and starting to really look at it as a not just what can the commercial sector do, but what should the commercial sector take on and what should the government keep.
What is the role, if any, of the commercial sector, not in the satellites looking down, right, collecting Earth observations, but the ones looking out at threats? Everything from the
Mhm.
near Earth objects to solar activity that could damage human systems. Is there a commercial side of that market, or is that still largely national and international based?
There is actually a very large commercial sector that is doing monitoring of objects in space, and looking at these potential collisions, and even providing services to other satellite operators to let them know, what's happening out there, and what they should do about it. So there actually is a quite a thriving commercial sector there. Uh, and that community is having the same question about, how much do we lean on this commercial sector as opposed to building up a better capability within the government, basically for the same reason as weather, right? That we want to avoid these collisions because it's going to avoid destruction of property. And also because the United States, of all countries, we use space the most, right? We really want to keep that environment usable. So we want to make sure we're not having collisions, not creating more debris. So there actually is a process happening right now to go from, the US military providing that service, which it's been doing last few decades, but kind of historically has had that, to now a civil agency. So it'd be within the Department of Commerce that would now be providing that space safety, space situational awareness kind of
Okay.
capability again to the world and for free. Um, and yeah, there's lots of debate in that community about um, how good should the government product be, right? And are they going to be in competition with these commercial actors, or how do they work together? So I think figuring that out and getting the right balance, getting the right coordination between government and commercial is a really important step.
You as an academic, Mariel, you have the opportunity to really dig into these issues and research and explore them and understand this intersection of the political and the space. But I'm imagining here some of my former colleagues at the State Department, right? The diplomats, whether they're political cone or economics, and they don't necessarily have this knowledge about satellite constellations and the evolution of this history, but they need to have it because this area of space diplomacy is clearly getting bigger and is going to be an issue that US diplomats and diplomats of many other countries are going to have to be engaging on immensely in the future. Where
Mhm.
can they go to get educated on this? Because you bring in people to be diplomats, at least in the US Foreign Service, and you're not bringing in people explicitly because of their knowledge of satellite uses and satellite data, but they're going to need to pick it up on the job somehow. How is that going to work? How do you educate people about space diplomacy who need to do it in almost real time?
Yeah, absolutely. So I will say there are a number of individuals at the State Department, for example, who do space diplomacy, as their job day to day, and those people are amazing in their ability to bring together these knowledge sets. But I think one of the things that they're realizing, or the community is realizing, is you need a broader awareness. So to your point, people who
Mhm.
didn't come in specifically in these space positions still need to be aware of these issues and what a big impact. If we do have some major collisions in space and we make that environment less usable, right? Or affect our ability to have GPS, internet, communications globally, uh, it's going to be a big problem, and people are going to notice. That's going to impact our daily lives. So it's this thing that to a large extent is happening down in the weeds, that but really could have this huge impact. And so I think getting a little bit broader awareness is really important. How do you
Mhm.
go about doing that? I think there are people out there, like the individuals that are at State Department already, like myself, so academics that are outside. There's also a number of nonprofits that are very active in this space, Secure World Foundation, for example, or Space Foundation,
Mhm.
that are actively trying to educate policymakers and the broader public about what's happening in space. Why are we doing the things that we do? What are the biggest priorities? And
Mhm.
also trying to coordinate internationally, because it can't be just the United States acting alone, right? We've got to do this in cooperation with other nations.
I'm thinking there are parallels here too. I go back 20 plus years, and it's the education process that had to take place for so many people in the government on issues of terrorism and the roots of terrorism. And then probably in the last 10 years, the best parallel is cyber, that there's so many people who never wanted to touch anything having to do with networks and computers who need to be conversant, at least at a fundamental level, on issues of cyber. And I feel like we're at that point now with some of these satellite issues and space issues more
Mhm.
generally, where a wider range of people are going to need to be conversant on these issues than they even know at the time. And yet, in the near future, it's going to hit them, right?
Yeah. No, and you're starting to see some of these nonprofits, for example, creating, primer documents and
Mhm.
things like that that'll get people up to speed. We're starting to see a ramp up of especially online sort of space policy 101 type courses.
Mhm.
And I think, yeah, there's gonna be more and more demand for that to quickly get up to speed on what's happening in this sector.
Well, certainly some places they can start are your book, Open Space, the global effort for open access to environmental satellite data, and a lot of your writings in space policy and elsewhere. Mariel, before I let you go, we do have to reach into our chatterbox to ask you a random question.
All right.
If you could convince the President of the United States to take one discrete action today related to national security, what would it be?
Oh my gosh. You know, I don't know if it would be practical in the real world, but I think finding a way to start to engage with China and have more dialogue just about what their intentions are and our intentions are in terms of the space environment, in terms of our developments in space, I think would be something that would be very healthy. I think one of the things that worries me in this area is we are making a lot of assumptions about what others, and particularly China and Russia, what they're doing in space and why they're doing it. And I think they're also probably making a lot of assumptions about what the US is doing, what Space Force is doing, what our intentions are.
Mm-hmm.
And there isn't a whole lot of dialogue that's happening right now. And that's true for various reasons. So maybe something you couldn't achieve right now, but I think that would be something that would probably make everyone safer if we could start to have those conversations.
Mariel Borowitz, thank you for spending so much time with us talking about these issues. I appreciate it.
Thank you. I'm happy to be here.
That was Chatter, a production of Lawfare and Goat Rodeo. Please subscribe to the podcast and find us on Twitter at ThatWasChatter.